Bismillah ar-Rahman ar-Rahim. This is Steel Structures class delivered by Dr. Qusay Al-Kaseasbeh from Mutah University. Today, inshallah, we're going to continue with chapter 3 and in section 3.3, effective area. So, you know, guys, that existence of connections all the time weaken the member. Okay, let's say connection دائما this is the weakest zone or region in the system, and the let's say measure of the influence of let's say existence or presence of connections, we call it joint efficiency, and this depends on many factors. One of them is material ductility, and you know what material ductility means. Ductility means if, or let's say, the material will undergo large plastic deformation before fracture، يعني راح تتحمل deformation بمستوى كبير قبل ما يصير لها breaking or fracture. Fastener spacing, which is bolt spacing, this between how much spacing we do have between the bolts, stress concentration at holes, and you know I mentioned that if we have a stress, so okay, stress is equal P over A. This is axial stress. If we do have holes, means less area. Okay. This area inversely proportional to the stress means more stress, okay? And we do have, let's say, another factor, a fabrication procedure, phenomenon known as shear lag, and this is very important one. All these factors contribute to the reducing the effectiveness of the member, يعني كفاءة المember, but shear lag is the most important factor here, and that's what we will let's say study here in the effective area. Shear lag, okay, happens when we have some elements of the cross section is not connected. Okay, means if we have let's say leg or L cross section, and assume this one is connected to something by bolting, any let's say custom plate here or whatever it is. Okay, so in this case, you know that this angle, this one here or leg, is connected, okay, by bolting. It might be by welding, and the other one here is not connected. Okay, so in this case, you will see that one leg is overloaded and the other one is fully unstressed. يعني هاي عليها load وهاي فعليا is not loaded. Okay, so in this case we should let's say consider the shear lag by reducing the effective net area. Okay, so هنا راح نعتبر هذا الفاكتور بنقلل من area reduction. Shear lag affects both bolted and welded connections. يعني ممكن يأثر على الbolted خلينا نحكي هون welded connection. And for, let's say, bolted connection, the effective net area is all the time equal AE is AN times U, okay? So in this case, for bolted connections, A, what we call it, effective net area, okay? Or sometimes we call it just effective area. And AN is the net area, which is the A gross minus area holes. And U here, what we call it, shear lag coefficient, okay? U is shear lag coefficient. Okay, and for welded, it's going to be same here. For welded, we refer to this reduced as effective area rather than effective net area. ليش طبعا هون يسموه؟ لأنه إحنا we do have no holes in the welding. Okay, طبعا لو هون سميناها شباب بالbolted سميناها effective net area, it's okay, it does make sense. But in the welded area we call it effective area لأنه إحنا ما عندنا net area. دائما الarea net بتساوي الاريا جروس بالولدد. طبعا ليش هون؟ لانه احنا في الولدد ما عندنا اي هولز، فهون look at this is the effective area is area gross times shear lag coefficient. ميزوا بين البولتد وخلينا نحكي هون الولدد او الولدد. Okay, let's move down and see how we find these ones, or let's say the shear lag coefficient for any type of tension members, except the plates and round HSS with L is greater than or equal 1.3D. هون بنحكي عن cases. دائما shear lag coefficient is equal 1 minus X bar dividing by L. X bar is the distance from the centroid of connected area to the plane of connection. Okay, فإذا كان عندنا مثلا هون L وهون خلينا نقول connected to another plate by welding or so هون عندنا ايش centroid. Okay, if this is the centroid and this is the plane of connection, هاي هي بتكون X bar. And هاي is given to you in the steel manual. معطى لك بالsteel manual. L is the length of connection. وراح نعلمكم كيف توجد the length of connection and how to do that. Okay. Let's move on and see how to do both, which is here. If you see here, guys, as I told you, this is let's say angle, and this is the connection. Let's say by welding, by bolting. So this is the centroid of this, and this is the plane of connection. So this is X bar. As we have many different cases how to find this here and here. So this is gonna be okay with the steel manual, which you can find it. For the length of connection, let's move to figure 3.8, and you will see here. Okay, in this case, the length, let's say, okay, this is a tension member, don't care about this. So here, this is the angle here, this is angle, okay? How do you decide this is angle? This is angle if you look at from here. إذا طلعت لهاي from the side view راح تشوف هذول الخطين اللي هم هون وهاي راح تشوف اللي هم هون. So we do have يعني احنا ممكن نقول هيك bolted هون in this case طبعا بأول case. وبهاي الحالة since they are like regular distributed موزعين بشكل منتظم فالآن راح يكون من آخر بورت لآخر بورت. Okay. In this case كمان bolted, but we do have two line of bolting. هون لما نحكي two lines هذا واحد وهذا واحد، هذا واحد وهذا واحد، هذول اللاينز. Okay. راح يكون بهذا الاتجاه هيك. Okay. So here بناخذ من the most extremist bolt يعني من أبعد اثنين هاي L. Okay. In the case of welding, if you go down, in the case of welding, if you see here, this is welded or welding هون. Okay. فبناخذ ايش؟ إذا كانوا متساويين بالطول فبناخذ من هون لهون طبعا. احنا هون نحكي إنه يكون الكونكشن أو sorry yeah connection or the length of connection is equal to, or let's say the connection. ليش ما أخذنا هاي؟ Okay. So because this is the length of connection, and once again here, of connection length in the direction of load يعني باتجاه اللود. Okay, باتجاه اللود يا شباب، مش هاي طبعا هاي. Same here. Why we are not taking this? Because the load is going this way. So and here so بناخذ اللي موازي لللود. طبعا هون we have different length L1, L2, so we will take the average for both. Okay, so these are, let's say, for any type of tension members, and we can find the X bar and L, which is the connection of the length, or sorry, the length of connection in the load direction. Okay, we do have many different cases here for the plates. Usually U is equal 1, okay, because the cross section has only one element and connected. دايما احنا بكون 1. Exceptions for welded plates, which is these cases. Okay, guys, these are the cases for the exceptions. This is going to be okay. So you can either, it's going to be given to you in the exam, or you can let's say find it easily using the equation, which is U is equal 1 minus X bar dividing by L, which is the length of connection. Okay. For different cases here, we do have round HSS. لما يكون length of connection is greater than or equal 1.3 D is here is the diameter. There are many cases. I would recommend you to read all of these cases. Okay. In addition to that, guys, sometimes if we do have, if you look at this one here, if we do have 3 poles in the direction of the loading, U is 0.6, 4U is going to be 0.8, and so on. These sometimes we are using it to start with assumptions. حتى نبلش فرض نختار هاي القيم. Okay, let's solve example 3.4 here and see how to find the effective net area. So in this example, which is 3.4, it tells us on page 56 to determine the effective net area, okay, effective net area for the tension member shown in the figure 3.12. Let me show you the figure so we can easily follow the solution here. So this is the figure here. If you look here, we do have a plate, equal leg plate, 6 by 6 by 1/2, means this. So this is going to be 6 inch by 6 inch by 1/2 as a thickness inch. Okay, it's here it's connected to a gusset plate with 2 lines of bolting, and the diameter for the poles is 5/8 inch, and here is the spacing. Okay, and here is the load direction. So this is the tension member here. Here, this is a cross section. So what is this distance here? If you see, this is from the centroid to the plane of connection. So this one is X bar. Okay, and here if we find the length of connection, you see it's going to be from here to here. So this is L, which is equal 3 plus 3, which is equal 6. Okay. So first of all, we need to get the gross area for the section, which is this one from the manual, part 1, as I did in the, let's say, previous class. So here, if you go to the manual, you will get the gross area is equal 5.77 inch square. I don't need to go there because I suppose you are right now familiar with the steel manual and how to get the gross area. Okay, if we take a section anywhere here, okay, you will see that the net area is equal the gross area minus area holes. So the gross area from the manual is 5.77 minus. How many poles we might, let's say, cut here? It's 2 poles. Okay, how much the thickness of the plate is 1/2. Okay, multiply by what is the diameter for the poles is 5/8 plus 1/8, which is the diameter for the holes. Okay, so this is the net area, and this one, as you see, it's equal 5.02 inch square. Okay, so this is AN, not AE. AE, which is the effective net area, is equal shear lag times net area, and this is the net area again. So the shear lag, how to get the shear lag? Shear lag, it's 1 here, if you see, 1 minus X bar divided by L. X bar here, it's given to us, is 1.67 here, dividing by the length of connection, which is from here to here, so 6. So this is the shear lag coefficient. Multiply it by this much, which is here, this times this one, so you're gonna get the effective area is equal 3.623 inch square. Okay. Right now it seems I have to go to check this value there and show you how to get it for, let's say, L angle. Since we are there, we will be able to see that gross area is equal this much. Let me go to the steel manual. So if you look here, guys, so this is the X bar or XP, okay? It's the distance from the line of connection here to the centroid of this shape, okay? Or let's do it here, it's X bar. Okay, so if we go down and find XLXX, it's multiplied by 1, which is this case here, okay? So the area is 5.77 as I told you, so this is the area, okay? And right now, if we go down, because here, if you go see, guys, we do have no X bar. So X bar here, which is either this, yeah, let's call this. I don't want to confuse you. It's this much, okay? So for this one, since we are doing 6 by 6 by 1/2, it's 1.67 here. Okay, 1.67. So this is X bar that we are looking for here. Okay, so we've done how to get X bar or the gross area. Let's get back to our textbook. Okay, so let's move right now to section 3.4, staggered fasteners. Okay, clean this, go down to section 3.4. You can solve, let's say, example 3.5 by yourself. This is for, let's say, welding. So I think it's much easier for you. Staggered fasteners, okay? So guys, if we do have, let's say, bolted tension member, the net area will be maximized if the fasteners are placed in one single line. Yani, let me tell you what does this mean, okay? So if we do have, let's say, a tension member, okay, connected to, let's say, cast plate or whatever, one single line is like this. It's one line, okay? It's one line. It might be 3 or more. 2 lines is like this. We have 2 lines. Sometimes they might be 3 lines, okay? So this is 1, 2, 3, and this is one line. So if we make a section here, guys, for sure we're gonna have one bolt cut it. That means the area net, which is area gross, minus area holes. Area holes is very small, so the area net is gonna be maximum. Okay, but if we do have more than, let's say, one line, that means the area holes will be more, and so the net area might be a little bit less. Let's see how we're gonna do that. Okay, let's assume we do have this line of bolting, okay, here, the one here at C. So if you see, this is path A, B, C, D, okay? The reduced diameter, which is for holes here, it's gonna be very easy later. D is, and let's D bar or prime here, is the whole diameter, which is the original one minus S dividing by 4G. Okay, so this is the reduced diameter. Okay, and this is the original one. Okay, diameter. So here, D is the whole diameter, as I mentioned. Let me make it nicer here and put it whole diameter. Okay, S is the stagger or pitch of the poles, spacing in the load direction. So this is the load direction, and this is the S between here and here. So this is S, what we call it stagger or pitch. دائما طبعا باتجاه اللود. ممكن كمان هاي تكون S. Okay. G is the gauge transverse spacing اللي هو باتجاه عمودي على اللود. فهاي مثلا بين هون وهون لو بنحكي هاي G. Okay, so that or these are the parameters for this equation here. And if we do have more than one failure pattern is possible or path, all the cases should be investigated. يعني إذا كان ممكن نفترض إنه هذا ممكن يصير الفيلير هيك، يعني يصير القطع بهذا الاتجاه. اوكي، وممكن القطع يصير بهذا الاتجاه. اوكي، فحسب شو هو ممكن يكون بهذا الاتجاه. ف we need to check all the things. We will see how to do that later here. طبعا in this case guys, if you remember, that was just like okay kind of shear, okay, or let's say tension here. Yeah. But in this case, let's say in BC here, we do have a combination between let's say shear and tensile. So this is going to be tensile, and we're going to have, let's say, shear here. Don't care that much about this point, okay? So if you know, guys, so this is the equation that we mentioned, which is this one here, and everything is defined here, okay? So you can get back to the textbook and read it in details. So the net area all the time is equal to thickness times the net width. Okay, net area, which is the thickness multiplied by net area. Oh, net width, sorry. اللي هو العرض لأن نحكي عن cross section فدائما هو الوidth بالthickness. And you know, if the staggered is equal 0 means the يعني هون دائما إذا ما عندنا staggered فدي reduce بتساوي الهول. In this case, we can say the net width is equal the gross width minus the summation of d prime. لأنه إحنا هون طلعنا thickness كأنه طلعنا thickness إيش؟ out. Okay, so in d prime here, as we mentioned here, is equal d minus s squared dividing by 4g and summation because we might have more than one here. Okay, لأن راح تشوف كيف راح نحل examples راح يكون أكثر منهم. أو ممكن يعني just to rearrange the equation. طبعا in this case for this one we can make it much easier. This is number of the hole diameters. هون a number of hole diameters. holes diameter. يعني قديش عندنا hole diameter. هاي كمان ضروري تركزوا عليها لأنه بعدين شوي راح نشوف إنه كيف ممكن هاي ترجعنا شوي. و in this case, this is number of inclined line. راح الكتاب بيحلهم بأكثر من طريقة أو concept حتى يعني يوضح لك إنه كل هاي الطرق is okay. So let's solve example 3.6 right now and see how we gonna do that. Okay. So in the problem statement says compute the smallest net area for the plate shown in figure 3.15. The holes are for 1 inch diameter ports. Okay. So الهول هذا إيش diameter port. Okay. So in this case, guys, let me see the figure 3.15. So this is the figure 3.15, which shows that it's a plate here, and we do have all the dimensions here and there, and we do have the paths. Okay, so let's check which one is going to be the smallest one, which is going to be the control. Why we are taking the smallest one? Because this is going to get us the more stress. Okay, so in the first case right now, we know that, or let's say the first step, the effective hole diameter is 1 inch plus 1/8, which is 1 and 1/8 inch for any holes. Okay, let's start with the path اللي هو AP or BDE. Okay, let me show you this here, which path I'm talking about. It's the path here, A, B, D, E, directly like this. So how much, let's say here, we can directly calculate the net area, or we can get the net width and multiply it by thickness. So the width here, the gross width, is equal 16 inch, 3 plus 5 plus 5 plus 3 inch. So for line here, if I'm gonna say for path or line اللي هو A, B, D, E, we're gonna have the net area is equal the net width, the gross width, which is 16, minus how many poles we do have? We do have 2 poles, and the thickness for this one is, the diameter for the hole is 1/8 plus here, or let's say minus. We do have no D prime because we do have no inclined lines. This is going to be 0. So in this case, it's going to be 13.75 inch. So the net area, it's going to be this much times the thickness, which is 3/4. Keep this one. We don't need to go this far right now. And let's call this path number 1. Path number 2, if we, let's say, let me pick a different color here. Take A, B, C, D, E. Okay, so this path. So how to solve this path? So line A, B, C, D, E. In this case, the net width, which is equal 16, the gross width, minus how many poles we do have? 1, 2, 3. 3 poles times the diameter, the original diameter, which one we know, plus how many inclined lines we do have? We have 1 here, 1 here. Okay, so how much G? S here, which is this distance, is a 3. And G here, or here, 5, 5. So this is going to be 2. S, which is 3 squared dividing by 4 times 5. طبعا هون يا شباب لو كانت هاي اختلفوا عن بعض تحط كل واحدة لحالها بدون ما تضربها بال2. بس هون لأنهم متشابهين ضربناهم مباشرة ب2. So this is equal 13.52 inch. Okay, and we can check more, let's say, lines here in this case, but this one is going to be the smallest. The one I just calculated, because if you compare this to this, this is going to be the smallest. Once you get the smallest net or width, net width, so the net area is equal the W times the thickness, which is 13.52 times 3/4, which is given here. So the net area is going to be 10.1 inch square. Okay, so this is the net area, and we can check more than let's say 1 line. So you can check this one, many here. You can check them. I don't want to go to this far. You can do it by yourself, since it's very easy to go with this one. So here, if you look at this one, and what we do, guys, here, just to find the net width is equal gross width minus how many holes. قديش عندنا holes نضربهم بالدايمتر لهم اللي هو دي، بنطرحهم من هنحكي اللي هو number of inclined lines لما نحكي انه summation of s square over 4g. Okay, we will continue with the staggered let's say area next class, inshallah. And if you do have questions, please send me an email, or you can chat with me on Microsoft Teams. Thank you.